Hi, welcome to the video tutorial for a lesson called Half-Time Scores. This was originally one designed and used in Year 6, but I just feel it's very appropriate to use in Year 7 as part of the algebra strand, expressing ideas algebraically. It follows on from Sports League and Roofs, or Roofs and Sports League, and I just feel it works very, very well. It's very challenging, and I think you've got to treat these video tutorials as a bit like a walk where there are certain viewpoints, and all I want to do is point out the viewpoints where it's productive to stop, so you don't need to reinvent the wheel. You know what's coming and you can focus on the thinking of the children, challenging the thinking of the children, exploring, probing the thinking of the children. For half-time scores starts, I always talk about when I was younger. My father was a fanatical Sunderland fan, poor bloke, and he, for some reason, he used to make me write out the football scores when I was like 8 or 9. It really annoyed me, and the football results would affect his mood. And so I would tell the pupils this, just reminisce, and I'd just say there was once when it never got any better when he got older. So there was once when I was about to take my children around to his house, and it was 3:45, and he said, "Alan, don't bother, don't bring them round. I'm in a bad mood. I'm not really very happy." And I thought, oh, right, okay. But then at 5 o'clock he rang me up and said, "Are you coming round?" He was really happy. So the suggestion there is at half time they were losing, but at full time they were winning. So I asked the children about that and get them to talk about what it might mean and say, oh, was it to do with the team and what was the score? He said, well, okay, at half time, what could the score have been? And they say something like that. They played well, but it was a draw. And then someone could do that and say they were winning at half time, or they were losing at half time. And you can explore the meaning of these conventions, that this is the home score, this is the away score. Some pupils won't understand that. So we agree that if Sunderland were playing away, so he's listening on the radio, watching it on Sky, and this was the score at half time. But by full time, it was 2-3. And they played a blinder, not for the last few seasons, so it was a while ago when we were talking about Sunderland. But you start saying, well, hang on, what else could the score have been at half time that made them so upset? Could it have been 2-0? Oh, that's interesting. I wondered how many possible half-time scores there could have been. Because maybe that's why people have this spread betting, the people bet on different results, because regardless of the full-time score, the half-time score could have been anything. So what I would do is I would give the people some football scores, full-time scores, and say 3-2, 4-1, 2-3, and 3-3. How many half-time scores could there have been with those full-time scores? And then I would allow them in pairs just to have a go at working it out. And so the first stage of the lesson is the people sharing their methods for doing this, and some will just do it in a very, very random way. They'll, for 3-2, you deliberately pick 3-2 and 2-3 because the results will be the same. But some pupils will say for 3-2, it could have been 3-2, 3-1, it could have been 2-1, and there'll be no system. Others will be more systematic. But it's very rare the first time through that they all get the same answer. So you'd have some feedback where you'd say to the class, okay, who got 3-2? How many half-time scores, possible half-time scores, do you think there could have been? And they'll say things like, we think there was 12, which is the correct answer. We think there were 11. We think there were 13. And you think, well, what is it? How are we going to work out what the correct answer is? And you let them explore. You let them explore systems and methods for writing it down and seeing how systematic it can be. And once you kind of reach a consensus that, well, actually, and someone proves it, that is 12, and then you realise that 2-3 is 12 as well, there's still some debate, there might still be some debate about that, because some might have 9, some might have 11, even though the correct answer is 10. And the same for this one. So there's a lot of confusion, but clarity is emerging as they do this. Who's got a good method? How are you going to show me? So that then, the lesson then progresses, a bit like sports league and roofs, where you just become more complex. So what you're looking for is the pupils have used this kind of system, a very systematic system, and you realise that it's the zero scores that are the key. That's where the significant number of games comes from. And what is really lovely is to allow the children to share their ideas and to share their methods, and for them to vote on which is a good method, so we don't make mistakes. We need to be very, very accurate. And it's lovely to give them that time where you've given them a range of scores, so 4-2, 3-4, 6-1, and they then refine their methods till it's more and more efficient. And in a bit like Sports League, where they see the one less because you don't play yourself, in this one they see the one more because of the zeros. And this is a very, very, I haven't got examples of people's work. The last time I taught this, I left them in the school, but this is a very rich piece of work, and most pupils in Key Stage 2 get to this stage where they're seeing the system and they realise the need for a good system. We're going to go to the next stage, which is where you're developing an algebraic understanding to express the pattern. But it's lovely to be able to walk around the class and pick pupils that have been very systematic and got a lovely method, so that others adopt that efficient method as well. Because you get to the situation where you have a range of full-time scores and you're thinking about the number of half-time scores. You've agreed that this one is 16. You've agreed that this one is 20. You've agreed that this one is 18. You've agreed that this one is 25. And you say, well, what about these? And then they can work on those, and then they can say, that's 35, that's 30, that's 36. Some pupils now will not be drawing it. Again, we're going through these stages of theirs. In the thinking maths lessons, you start with the context, the football scores. You've mathematised that, so looking at commonalities and different ways of sequencing and organising and being systematic. But then you're making the leap to generalising the formula. And some pupils will realise there's some patterns in here. And this table, it's lovely then to move to this table and say to the pupils, can you spot any patterns? And obviously having these ones here is the key, because they suddenly realise that, because if we go back to here, because of the zeros, you're getting more than you expect. So this one, if you include the zeros, is actually 4 times 4. So they start to realise that to get the formula, you need to get the away score, the home score, add 1, times by the away score, add 1. That's a full-time score. And how they express that is really, it's a really lovely activity, because you can bring in brackets, it's very, very rich. But what you want to say is, oh, you always add 1 to each one, then times it by itself, times them together. But I think you find that a very fruitful activity for children going through these stages, but starting to see the patterns. And there's several lessons in the Strand that repeat that. But it's often this one that they spot. But I wouldn't lead them to that. I would put them and say, anyone, how can we work it out? What if it was 10-10? Could we work it out in getting bigger and bigger numbers? And usually that way, some of them will, because they've gone through the stages, they'll suddenly move to seeing the pattern. They always add 1 because they've seen it from the way that they express the pattern and draw the numbers. And that's half-time scores, and it's the third in the algebra strand. And the next one is called pencils and rulers. And what we're doing is we're moving then to look at introducing children to solving simultaneous equations.